carrying on the further session. Thank you, sir.
Good morning to all of you. Thank you, actually, ma'am. And I'm to give you guys opportunity to share knowledge to you. This program. Okay, so we'll start with this session. The topic is significance of power electronics in electric and hybrid electric vehicles. Okay, so this time we are going with this electric vehicle system, and yes, nowadays you are seeing outside of the or on the road like electric vehicle are there. So the curiosity always in our mind to yes, what is inside. So as you know, as an electrical engineer, we know this is the system that is name is a drive. Okay, so everybody knows in drives having a major components like source, power converters, and motors, and some feedback system as well. So these are the major components, and that system will having so many things which is develop the electric vehicle. So before the starting this session, I will discuss some content. Yes. So we'll discuss some introduction related to the electric vehicle, and history will also discuss, and what need of the electric vehicle electrification, because we already using a IC engine based vehicle. So why we are moving on that side, and significance of power electronics, that is that is two guys actually. Significance of electronics in electric vehicle and hybrid electrification of the vehicle, that is also a important thing which is discussed in the session, and hybrid electric vehicle mode and operation, and some challenges electrification in electric vehicle and harmonic distortion, because that is very important, and that is my PhD area. So that's why I have included this portion in the presentation, and why it is need we'll discuss. Okay, so first we have discussed the history of this electric vehicle. Electric vehicle is nothing but a system that is used to use the electric power to propulsion, and that's eliminate a need of traditional combustion engines. So will replace by the internal combustion engine. And yes, it is a system which is based on the battery, and that is in plug-in hybrid electric vehicle, that is in short PHEV, and hybrid electric vehicle, and yes, that is in short we call electric vehicle. So normally the electric vehicle is based on the which is coming in the market or on the road, that is a battery electric vehicle. And yes, some higher version which is also provide a hybrid electric vehicle, that is both the way, that is based on the IC engine and battery based, and some other vehicles also having with renewable energy sources and battery. Okay, so these are the things which is having in the this electric vehicle. So this is in respect of the history. The concept of electric vehicle dating back to the 19th century. Okay, and earlier explained with the electric propulsion, including the invention of electric car by Thomas Edison in 1834. So we are moving on this side of the research or implementation of electric vehicle, but with very long time we are using a electric traction system. In electric traction system also electrical drive. Okay, so in that drive we are using a DC motor that is directly operated by the AC supply. Okay, so some converter is there, but now we are moving on the research coming on this research, we are going in the roadway, or we can say electric vehicle side we are moving. And yes, rise of electric vehicles. So recently, surged in interest of adoption due to the environmental concern, energy efficiency, and advancement of technology. Yes, that is why it is possible, because that is an advancement in the technology. That's why we are thinking on side of the electric vehicles, and yes, that is important for the environmental concern as well. Okay, and environmental benefits. What are the environmental benefits are there? So that is a zero emission. You know, when that electric vehicle are moving on the road, so there is no emission. Emission is there. It means it is clean, and no pollution will be created in respect of the that is sound and other things as well. And yes, we are also not polluted. So that is reducing the greenhouse, that is important, the greenhouse gases, and lower carbon footprints are there. So that is the important with this with the this electric vehicle. And yes, technological respect advancement, so improvement of the battery technology, increasing energy density, large range, and faster charging. And one more thing, that is in the advancement in the converter as well. Because long back we are having some limited components, and that components having some challenges. Now we are also developed, engineers are develop a very advanced component that is and using very easily. Okay, but only it is required some basic knowledge, which is already we have seen in the literature or studied in the past. So yes, that is possible by advancement in the converters, or not only converters, that is advancement in the semiconductor based device as well. And yes, government support are there. Many countries are providing some benefits, or we can say compensation in respect of the when you are using electric vehicle, because that is definitely that is not effect to the environment. And challenges and opportunities. What are the challenges? Yes, so many challenges with this, because electric vehicle nowadays we are using, and that is a battery operated or some renewable energy source based. But that battery manufacturing and other things are again creating a, for development of those things, to creating a pollution, because then it is manufacturing, so definitely it will be polluted the environment. So that is the concern. And yes, the generation nowadays, that is totally not totally depends on the non-renewable energy source. Still we are using a fossil fuels. Okay, so generating a power by the fossil fuel, and that same power we are using in electric vehicle. So it means that is directly and indirectly still we are polluting the environment. So engineers and researchers are doing on that side as well, to generate a power by the non-renewable energy sources. Okay. So yes, so some and one more important thing with this challenge, that is the infrastructure. I'm also having electric vehicle, but I'm also thinking when going on outside of the Bhopal. So yes, this side is charger is not yes or not. So first I'm finding the charger. If charger is there, so I'm going on that side. Otherwise, I'm not moving on. So that is the thing. So infrastructure is very important for this electric vehicle. You know, traction is also a traction system, also a electric uh, electric system, but it is having a separate line, power line. So that is possibility is there to move in any way, which is track is there. Okay. And yes, range anxiety. That that is also important because that is a simple example like a mobile phone. If your mobile battery is discharged, so again it is anxiety is created and we are always thinking of yes 5% is remaining, 10% is remaining. So same thing will happen in this side as well. So that is only when you are using a battery operated electric vehicle. Suppose if you have other option like hybrid vehicle is there, so that will be that time you will move on the other side. So that is anxiety will be there, and the opportunity of the innovation is charging solution and energy storage. Yes, because the power storing capacity is limited, or we can say that is limit in particular vehicle. So that is also a problem. So suppose if the backup is there, so that is a possibility to extend the range. If backup is not there, so that is the problem to limit the range. Okay. So electric vehicle represent a pivotal shift in the automotive industry toward the more suitable and environmental friendly feature. Okay, and lower carbon footprints EV can be powered by renewable energy sources. So that is the thing. And yes, what are the needs? Okay, needs of electrification. So why required this need to electrify the vehicle basically? We are already using nowadays we are also using IC engine. So why it is a need to electrify the vehicle? So that yes, that is it. Environmental sustainability is there and reducing the emission as you discussed previously. Energy efficiency is there and reduce the dependence on fossil fuel. So these things are already discussed. So yes, in the detail is there. Means when environmental sustainability, definitely it is climate change mitigation is there, reduced emission and in efficiency, higher efficiency will get when electric motor are using, because in the IC engine at some in IC engine so many losses are there when you are using a motor. So that is as compared to the IC engine that losses will be less. So if you are using a motor and high efficiency motor, so that definitely the efficiency will be more of the particular vehicle. And renewable energy integration is there. So yes, if you are using a IC engine, and yes, if you want to uh, integrate the renewable energies, so again it will require some other system which is also reducing the efficiency. Like suppose I am using a IC engine, and if you want to synchronize with the fuel cell, hydrogen based fuel cell. So yes, that is because pure hydrogen is required and it is converted to electricity, and that again that electricity will require a propulsion or the rotating motion. So we require a motor, then that motor shaft will connect with the IC engine. So this type of system will require. So system will be lengthy and complex, and yes, when system is lengthy and complex, so efficiency automatically will be reduced. So that is the thing with the energy efficiency. And reduce dependency of fossil fuel. Definitely, if you are not using a fossil fuel, or if you are using electricity, so that electricity nowadays we are generating by the renewable energy sources. Okay, so diversification of energy sources will be there. Like hydrogen we can use, solar energy we can use, wind energy we can use, and this tidal energy we can use for generating electricity. So diversification is there, and yes, energy security is there. Less reliance on imported crude oil enhanced to national energy security. So that is the thing with the, and yes, air quality improvement. As you know, we have already discussed that is reduce the emission. So there is no pollution in the air pollution in there. And yes, technology advancement, that is very important for the electric vehicle. Battery innovation and ongoing advancement of battery technology are improving the energy density, reducing cost, and extending the range of electric vehicle. So yes, previously we are using a lead acid battery, and now we are nowadays we are using a that is nickel chromium based battery. And yes, sulfate based battery also using. And yes, in the researcher they are going to develop a iron based battery as well. Okay, so that is the advancement. And yes, they are engineers also doing that, researchers are also doing to extend the range of that particular battery. Okay, and yes, smart charging infrastructure. Yes, it is also related to the power electronic devices, okay, or power converter based. So smart charging infrastructure means we can use the wireless charger or wire-based charger. Is so will increase the capacity. This type of system are required. When you increase the capacity of the particular charger, so then will also require high capacity of the converter. So when you increase the capacity of the converter, so the cost of the particular converter will also increase. Okay, so that is the advancement in technology. And yes, government policies and incentives. So some government are providing the incentive, some government are providing the some government are providing pushing to purchase electric vehicle. Okay, so and incentive also providing. In MP government provide the transition in the transport registration. Okay, and yes, cost sharing is there. Uh, because we are using a fossil fuel, that cost will be more, and when you generate electricity by the non-renewable energy sources, the renewable energy sources, the cost will be less as compared to the generated by the fossil fuel. Okay, and consumer demand and perception, that is also challenging to preference, increasing awareness and concern of the environment, drive consumer interest to the cleaner and more sustainable transport options. And market trends growing to consumer demand of electric vehicle, increasing the automakers to invest in electrification. That is related to the market, and we are more focused on the other thing. Okay, so that is the part actually. So that's why I'm discussing that. And global sustainability goals also there, and innovation and economic opportunities also there by using electric vehicle. And yes, significance of power electronics in electric vehicles. So suppose in place of the IC engine, we are using a motor, because in the propulsion will require the IC engine in transport, and yes, in propulsion we can use motor. Okay, so both type of propulsion we can get, rotating also and translation motion also. Okay, so for the translation motion, we'll use a linear motors. Okay, in manual train and fast train are using this type of propulsion system. Okay, and yes, efficient energy conversion is there. You know, when using a semiconductor device, as you know, that losses of the particular device, that will be considered as a negligible, or that is very minimum losses will be there. So that is the advantage with the power electronics devices or the component. So suppose if you are using these component to develop a converter, so definitely the losses will be less. So that is the, and automatically when you using power electronic devices or semiconductor devices to develop a power converter, so automatically efficiency will be increased. Okay, so that is the thing with this to increasing the energy efficiency of this converter or the electric vehicle. Power electronics facilitate the efficient conversion of electrical energy between the battery and electric motor, because 40% we are using a motor. Okay, and that motor to provide the power definitely by the source that is a battery, but still we cannot directly connect with this battery with the motor, because our aim to provide the variable speed. Okay, to get a variable speed, so that will require a converter. So that converter will uh, provide the medium to flow of power from battery to motor. Okay, and yes, that according to your requirement, you can vary the speed of the motor by controlling the power converter. Okay, so that is the thing which is efficient energy conversion, and variable speed we are getting. So variable speed definitely nowadays we are controlling all kind of motor by the power converter. Previously we are using a different conversion, mechanical conversion to control the speed of particular motor. But in the advancement in the power electronics or in the converter, we can directly provide the power via power converter and to control that motor. Okay, so previously the speed control of the DC motor will use the either we can change the armature current or field current, or both we can change to get a variable speed. But after advancement in the power electronics converter, we can directly get a variable speed by controlling the poles only. Okay, so that is the benefit with the power converter. Okay, and just to get a variable speed, and just regenerative, that is the feature with the motor to generate to get a regenerative braking. And yes, I think most of the audience have a knowledge of the regenerative. What is the regenerative braking? Have you idea about the regenerative? Simply, that is if you are providing the propulsion by the motor, and same motor suppose in low load condition will use as a generator, so it means that is a regenerative braking will be happen. It means suppose uh, have you ever idea about the lift? That is the best example actually for the drive. Have you ever idea about the lift? Student, लिफ्ट का आइडिया आप लोगों को? ओके, सो यू नो इन द लिफ्ट आप लोग ने देखा होगा, लिफ्ट में एक केज होता है, केज के साथ एक लोड होता है, ठीक है? सो दैट लोड विल मेंटेन द inertia basically. Okay, and yes, and it is providing the it is also supporting to removing the drum. Okay, so suppose in the same system we are generating a power. How can we generate a power by that same system? You know, suppose your load cell will be there, and that load cell will and cage will be empty. Cage means lift यदि खाली है और यदि आपके पास उसको लिफ्ट होकर ऊपर जाना है, ऊपर जाने से मतलब यदि ग्राउंड फ्लोर पे है तो यदि फोर्थ फ्लोर पे जाना है तो, और केज है वो एम्प्टी है, मतलब लिफ्ट जो है एम्प्टी है, तो उससे क्या होगा, लोड सेल नीचे आएगा और लिफ्ट खाली रहेगी। तो उस टाइम पे जो लोड होगा मोटर पे वो कम से कम होगा। गेटिंग माय पॉइंट? तो उस टाइम पे यदि मुझे उसको एज अ रीजनरेटिव चलाना, सो दैट विल प्रोवाइड द रीजनरेटिव एज वेल एज दैट विल जनरेट अ पावर एंड फीड to the other storing system. Okay, so that will be a possibility with the regenerative braking. And it means that is simply when regenerative operation will happen, it means the direction of the current will be changed. That is the simple thing with the regenerative braking. And that simply rotating torque will oppose the generating torque, so that will happen with the regenerative braking. So that phenomena in the regenerative braking. So what is the advantage with the regenerative braking? That is provide the brake as well as it is generate a power. So same power we can store in the storage device. So that will be possibility with the electric vehicle, and that is not possible in the IC engine. Okay. Have you idea about the IC engine? IC engine में क्या करते हैं? Braking कैसे लगाते हो आप? Manually braking is there, है ना? Brake shoe is there, and that brake shoe will tie to the drum, and braking will be happen. Okay, but in electric vehicle system, we can provide the electrical braking, and with that we have a facility or we have an advantage to generate an extra power. Okay, so that is the regenerative braking and optimized battery charging. Yes, again that is thing कि आप यदि इसमें बैटरी चार्ज करना चाहते हो, how can it possible? Yes, because that electric vehicle is a battery operated vehicle. Okay, so battery operated vehicle, if you are utilizing that battery, how can we optimize to utilize the battery? Okay, if there is no need to accelerate the vehicle, so we'll remove the supply. Getting my point? Suppose आपको motor नहीं चलाना है, so simply you can disconnect the supply from the battery, isn't it? But in the IC engine, continuously engine will be going on and working on. Okay, but in the electric vehicle, there is, if you are removing the supply, so battery power will be saved. Okay, and yes, in that condition we can apply the regenerative braking to generate an extra power from same motor. Okay, so that is the benefit of the this optimized battery charging. And yes, DC AC conversion or AC to DC conversion. Yes, so many converters are there in the electric vehicle. Basically, bidirectional converter will use in the electric vehicle. And yes, that why it is required a bidirectional charger? As you know, अभी हमने थोड़ी देर पहले डिस्कस किया that motor will supply by battery. But when you generate a power by same motor, so that power will again feed to the battery. So will require a bidirectional converter. So that bidirectional converter will provide a supply to the motor, and same if you require store that power, so same converter will use to store that energy which is generated by the motor to the store in the battery. So that is the benefit. And yes, it is required bidirectional converter. And suppose your motor is AC, so we'll convert that because we'll store the charge of the energy in the battery. So, and you are using an AC motor to propel the system. So, in that time, it requires a conversion of DC to AC. Okay, and yes, on board charging. Yeah, in the next thing. On board charger control. It means again it is required a bidirectional converter or unidirectional converter is there. Okay, so suppose bidirectional converter you are using, so same electric vehicle we can use as a backup or to electrify the house or whatever system is there that will be electrified by the electric vehicle. If you are using a bidirectional converter, getting my point? यदि आप उसको व्हीकल को चार्ज करना चाहते हो, so you can use that charger or converter or charger to charge the battery. And say other side, यदि आपके पास supply नहीं है, so you can use that same electric vehicle as a backup system. So it is required a bidirectional converter in that time. Okay, so unidirectional converter will not done those things. Okay, so onboard charger control is required. And yes, thermal management. Yes, very important thing because semiconductor device is very delicate device. If you are not operating in proper manner or not operating up to mark, that will be failure, and yes, that will be cost. That will be increase the cost of the system basically. You can say if you are not providing the protection system in that electronic devices. And yes, thermal management is required because that vehicle is working continuously. So heating will be there. So that will be managed by this electronic system. Okay. And yes, reduce the energy losses. Through size control of the management, power electronics minimize energy losses during the conversion and distribution of electric power and enhance the motor control algorithm. Again, engineers are working to enhance the control algorithm because still, control algorithm. Control algorithm is nothing but a logic to control a particular motor. Okay, or we can say the speed of the motor. Okay, whatever you require. Yes, significance significance of power electronics in the integration between energy storage system, adaptability of various motor type, smart grid integration, reduction of maintenance and noise reduction. So these are the significance of power electronics based EV and hybrid EV. Okay, so I'm not going to same things are there actually. Okay, so we'll discuss the classification of the electric vehicle. So based on the purpose, based on the purpose, that will be a either is passenger vehicle, commercial vehicle, uh, emergency vehicle, and military vehicle. All the vehicles have a different features and importance. So passenger vehicles, yes, it is based on the size, it will require a power. Okay, commercial vehicle again based on the size, based on the requirement that will be achieved, and based on the load capacity. So light duty vehicle, that means passenger vehicle will be there. Medium duty vehicles is there, and heavy duty vehicles is there. Medium duty vehicles means that is a what we can say simple buses is there. Okay, transport purpose we are using. And heavy duty means that is like in train or tramway that will be used heavy duty vehicles. Okay, and based on the fuel, that is gasoline vehicle, diesel vehicle, electric vehicle, and hybrid electric vehicle. Okay, and based on the tender capacity, that is on-road vehicle, off-road vehicle, and alternate vehicles are there. Based on the body shape, different shape are there. Okay, that is the sedan, SUV, hatchback, uh, and vans, tracks. These are the based on the body. Okay, based on the construction. Yes, that is conventional vehicle, electric vehicle, and hydrogen fuel cell vehicle. And based on the drive configuration, yes, is front wheel drive, rear wheel drive, all wheel drive, and four wheel drive. So based on the drive vehicle, yes, in this section also engines are the thing. Four wheel drives and all wheel drives. Okay, so four wheel drive, all wheel drives have a means, we can control in any direction by controlling a four wheel drive. Okay, and yes, it is. And when you considering a four wheel drive or individual four wheel drive, so that complexity will be there, but the efficiency will be increased when using this type of four wheel drive. Based on number of wheels, yes, two wheel, three wheel, and four wheel, like auto rickshaw and four wheelers. Okay. Based on the autonomy, based on the technology, yes, conventional technology will be there, and connected vehicles and smart vehicles are there. So Tesla are developing this smart vehicles. Okay. Based on the energy sources, IC engine are using fossil fuels or diesel batteries. Okay, electric vehicle are using a battery or fuel cell and other renewable energy sources. And yes, based on size, based on the public or private use, based on the specialization, and based on the emission index. So these are the classification of the electric vehicle. Now move to the uh, transportation. Uh, Okay. So yes, based on that, this transportation, conventional, IC engine, we are talking about the IC engine. That is, the fuel is there, engine is there, and that will be create a transmission, okay, or propulsion. Now in the hybrid electric vehicle, we are using a both the system, IC engine as well as the electric system. So IC engine and electric system have an advantage. It will be provide propulsion by this IC engine and this battery operated system as well. So what is the advantage if you require a more thrust? So we can use both the things. And if you not required high power, in that time you can use either this battery or IC engine. Okay, so these both system we can use. And yes, one more advantage with this system, we can suppose this system operated with the IC engine, and that we have a translation motion, so we can develop the energy by connecting a generator and feed to the battery. So that is a advantage with the hybrid electric system. Fuel cell based system. Fuel cell based system, it means it is not having a IC engine. We can use an optional, that is a fuel cell, or primary we can say we can use a fuel cell, and rear you can use the that is battery. So that is the fuel cell based system. So primary source is hydrogen for the fuel cell, and yes, it is also similar like a battery, but it is primary source is a hydrogen. And yes, that is electric vehicle, or we can say that is a battery operated electric vehicle. Only it is having the battery and motor converter. So that is in block. When you study this thing, so that is looking a very simple, but it is having a very complex thing to done this type of operation. Okay. Now hybrid electric vehicle mode of operation are there. So yes, hybrid. Yes. Actually, okay. So hybrid electric vehicle mode of operation, and yes, for the start at low mid-range speed. If you want to start with the low and mid-range speed, so we can go with this battery operated system. We cannot use this IC engine. Both system is there. Means this is a hybrid system. It is having a IC and IC engine and battery operated system. But for start or low mid-range speed, we will done by the battery operated system, or like a battery operated electric vehicle. We are not using this system and driving under a normal condition. So in the normal condition, you can see we can use the this IC engine, and this IC engine will generate a power to stored in the battery. So that is the for the under normal condition we can doing like that. And sudden acceleration are required. So as you know, previously I also told same thing. If you are required a sudden acceleration or high thrust, so in that case we use this two system. Okay. And yes, for that we can also use, engineers are working with the ultra capacitor. So for impulse power if you require, so we can use the ultra capacitor, because in short duration it will give the high power. So in that case we use the ultra capacitor, like rocket launching, and fighter tank is also required to provide a high thrust in very short duration. So in that case, we use the ultra capacitor. Okay, and yes, for the deceleration, as you know, मैंने थोड़ी देर पहले बताया कि आप deceleration कर रहे हो, it means when you provide a brake. So in that time we are working on that side, or we can say you can use this system to generate a power by braking condition. Okay, so this is the mode of operation. In this four mode, we'll use the converters. Okay, differential converter. So that converter will do that operation. So component, what are the component for the electric propulsion system? So yes, that is electric motor are required as a major component or main component for the electric system. And yes, power. So that purpose is what converts the electrical energy to mechanical energy for vehicle propulsion. And one more thing it is doing, that is generate a power and store it the battery. So bidirectional operation will be done by the electric motor. And yes, in that mode, for that operation will be done by the AC motor as well as the DC motor. So AC motor, yes, induction motor, synchronous motor we are using. Okay. And yes, induction motor, that is normal induction motor will also use, and linear induction motor will also using for linear propulsion. Okay. And synchronous motor we are also using, and yes, the efficiency of the synchronous motor will be more as compared to the induction motor. But only thing is that to controlling this synchronous motor, complexity with this controlling of the synchronous motor. Okay, but efficiency will be more. And DC motors, that is brush DC motor will also use, and brushless DC motor also use. So yes, when using this motor, so accordingly will require a converter. Okay, to convert as required the power by the motor. And yes, power converter, as you know, we have already discussed what is the purpose to manage the flow of electric energy between the battery and electric motor. So that is the mediator. Whatever energy is required for the motor, that will be provided. Suppose in the starting of the static thrust is required. So accordingly, that converter will provide the power to the motor, and in the steady state condition, that will be maintain the power of that. And yes, the low power operation condition also will done by this power electronics converters. And yes, battery packs, that will be stored the electrical energy for use of the electric motor. Okay. And yes, lithium ion nickel metal hydride, so solid state batteries are using. Okay. And yes, charging station. So that will be provide the power, or we can say that will provide the power or to charge the battery which is having in the electric vehicle. Okay. So it is also having an option to onboard charger and offboard charger. That is, onboard charger, it means it is having a onboard charger. It is having a separate converter on the board. Offboard charger means that is not having in the board. We are using a separate charger to charge a battery. So that is a offboard charger, and onboard charger, it means it is having a separate converter or charger which is charged to the battery. Okay, so that is the difference between onboard charge and offboard charge. I guess thermal management will be there, we already discussed. And yes, that is energy management system is there, that is already discussed. And energy management system is there, and electric transmission is there. Okay, the transfer the power from electric motor to the wheels. Okay, and regenerative braking, as you know, we already discussed, and the power distribution units. So power distribution, electrical power from the battery to the various vehicle components. Okay, like fuse, relays, circuit breakers, so, which is having in the electric vehicle, and electric power steering. That is provide a power assistant to the steering using the electric motor. Okay, and that is means that is simple. That will whatever power is required to the motor, that will done by this converter. Auxiliary system, as you know, when you are sitting in the electric vehicle, so will require a fan, AC, lights, and other accessories to operate. So that auxiliary system will be there. And yes, that auxiliary system again will require a converter. So in place that system, we use the auxiliary converters as well. And yes, vehicle control unit, that is vehicle control unit is nothing but a brain of the EV. So in that brain of the EV is not only a power converter, it is having a digital controller as well. So as you know, previously that analog converter is there. So that analog converter, the response will be slow. So we are using a digital controller. Response will be fast because for the in accident there is no option to take a decision. So according to the quick decision will require a fast converter or fast controller as well. So in that purpose we use the digital controller because the digital controller response will be fast as compared to the analog controller. Okay, so yes, we will require electric vehicle charging infrastructure already discussed. Onboard diagnostic is there, that is a monitor and report the health and performance of electric propulsion system. So that is onboard diagnosis system. That is the system which is providing the information actually which is done in the EV. So that onboard diagnosis system will give the information. It is nothing but a combination of different sensor or feedback systems. Okay. So these components work together to deliver efficient and sustainable electric propulsion in modern electric vehicle. The specific design and implementation can vary among the different electric vehicle model and manufacturers. What are the challenges in electrification of electric vehicle? What kind of challenges will happen? So these electrification, yes, when you see this challenge and you can find the gap where it is required to or it is required to work on that side. Okay, so that is the challenges when you find. Okay, so the electrification of vehicle bring about the numerous benefits, but it is also present of various challenges. Here are some of the key challenges associated with electric vehicle electrification. So limited range, one already discussed, but that is very very important. Limited ranges means that is if you having a 24 kilowatt battery backup charge. So only according to that range will be given. And when you increase that capacity, then only condition to increase the limit. Charging infrastructure, as you know, charging infrastructure is very very important. And with that, it is a high charging station as well. Suppose आपके पास charging infrastructure है, but that is a limit to the current, like it will take it to charge a particular vehicle in suppose same vehicle you are charging with 7 hours and same vehicle you are charging with the 1 hour. So it means definitely that is the capacity of the charger. Okay. So it means if you are charging same battery with the 1 hour, it means we are providing the more current or that current capacity will be more on that charger. You know, getting my point, students? है ना, चार्ज यदि आपको करना है, you know how example आपने देखा होगा कि अभी जो मोबाइल फोन आते हैं that is a fast charge, fast charge, 3 ampere, 2 ampere like that. So in fraction of second, half an hour and 20 minutes it will be charged 80 to 90%, isn't it? So what is the thing? That size of the charger will be more as compared to the previous one, isn't it? So in that charger will give the high current to charge a particular battery, isn't it? So same thing will be happen in the this electric vehicle as well. So यदि आप इसमें fast charger लगाओगे, fast charger means you are increasing the capacity of the current So the battery will be charging fast, isn't it? And if you are providing a less current or small current to charge that particular battery, so it will take a time. That is the simple thing. And yes, yeah, that is related to the charging speed, charging infrastructure and charging speed. So that is also important. यदि आप उसमें charger का capacity बढ़ाओगे तो what is the when you increase the capacity of the charger, what will be what infrastructure is required and where we are changing. यदि मुझे fast current चाहिए तो मुझे कहाँ changes करने पड़ेंगे? Charger. And yes, and primary source was grid. So we'll also increase the size of the transformer as well, जो charger से connected है, isn't it? Yes. So if you are installing this stuff or you are developing those things, so whole infrastructure are required to change. And battery technology and cost, definitely the technology are changing, but still the cost of the battery is more nowadays. And recycling and disposal of the battery, that is very tough thing, or we can say we cannot avoid those things to recycle and dispose them, because it is take a much more time to dispose this. Okay, so we have a challenge to recycling and disposal of batteries. Manufacturing emission, as you know, मैंने आपको स्टार्टिंग में बताया था कि जो मैन्युफैक्चरिंग एमिशन that will create a pollutant to environment basically. Okay, and market acceptance and consumer awareness, that is very very important. हमारे यहाँ पे यदि व्हीकल का देखा जाए तो I think 5 to 10 year back से चल रहा है, but still consumer are not accepting those. Very limited customer are purchasing the electric vehicle just because of this complexity and infrastructure and cost as well. Okay. Supply chain and raw material, because all the dependency of this primary source of the material of electric vehicle, like semiconductor material, we are importing from the other country. Battery material we also are importing of the other country. So that is the supply chain which is impact the cost of the electric vehicle, isn't it? And weight and vehicle design. Okay, so definitely primary source we are taking from the battery, and if you are increasing the capacity of the battery, so the size will be also increased. Okay, and when size increase, so definitely the weight will be increased. Okay, so that is the thing with the electric vehicle design. And grid capacity and electricity demand. That is, as an electrical engineer, you know very well electric capacity, grid capacity and electricity demand. Now again, I am coming back with the infrastructure. So if you are develop the high capacity of the charger in particular place or in side of highway side, but that grid supply will not a continuous. What will happen? What will happen? When you require a charging, electricity is not there. So again, that problem we are facing, especially in rural area. Electricity is not provided 24 hours. Okay, so that is the problem with this demand, electricity demand and capacity as well. Suppose high capacity charger you are installing in the particular place. So that time, the demand and in that duration, charging duration basically, the demand will be more, because that time. Suppose आप charger की बात करें, एक जो charger है जो off-board charger है, that taking a 7 ampere current at a time. But on-board charger that will be taking a 60 ampere at a time. So you know that capacity will be more. So in that time, the demand on that section will be high. Getting my point? So the demand of the for the very short duration, the demand will be high. So accordingly, you can develop the infrastructure. Getting my point? आपको उसके according उतना infrastructure बनाना पड़ेगा, but very short duration. short duration के लिए, but infrastructure is required to develop. भले वो कुछ देर के लिए आ रहा है, 1 घंटे में चार्ज करके निकल रहा है, लेकिन that 1 hours that demand will be more. Okay, and after completion of charging of that vehicle, what will happen? Again, the demand will be less. So that is the thing which is happen in the as a challenge in electric vehicle. Yes, power electronics converter for electric vehicle. These are the converter which is required to in the charger and converters to provide the supply to the motor. Okay, so onboard charger it means that is again a charger, AICTE charger which is installed in the charging station. DC converter is required when you use it. Yeah, your primary source was not renewable energy sources like आप यदि power generate कर रहे हो solar energy से, so that will convert to first in DC, constant DC basically, and that DC will feed to the your vehicle back to charge a battery. So there will require a DC charger, and that is a bidirectional charger. Keep in mind. Inverters are again that is suppose you are using a AC motor, so that is required, and yes, your primary source is DC, so that will require to convert in AC first. Okay, and battery management system. Yes, as you know, in battery management system, as per the the battery is what? That is a combination of cell. Getting my point? Battery is what? That is a combination of cell. So if you are splitting that battery in different multiple battery, so we can manage that battery charge as per your requirement. Okay, so that is also a technology to charge a separate cell or to find a status of that charging of that particular cell. Okay. So battery management system is there, and motor controllers. Yes, this is nothing but a motor controller is what? This is nothing but a converters. Okay, converters हमें कहाँ मिल रहे हैं? एक converter जिसे charger पे use हो रहा है, and second converter which is provide the power to the motor. Okay, so these two converters are major two converters are required. Yes, as you know, that is bidirectional charger or inverter is there. As per the requirement, as per your demand, that will be used. Okay, energy recovery system. So energy recovery system is also done by the converter only. And isolated converter. Why it is required isolated converter in the electric vehicle? Isolated converter is required. Why it is required? Think about that. Suppose in electric vehicle you are providing the power by battery to the motor. So dedicated converter is there to done those things. Okay. So suppose for and other auxiliary converter are going to provide the to run the AC, fan, lights, and that primary source of the particular converter as well. Suppose यदि वो separate converter नहीं होगा तो क्या होगा? जैसे ही कुछ fault आएगा and that auxiliary converter will also off. So it is required a isolated converter, and that isolation will also done by the not electrically, that is non-electrical connection will be there. Like for the communication we are using fiber optic cable. So these type of cables will use to isolate the non-electrical to electrical system. Okay, or it will provide a direct connection with the converters. Okay, to avoiding the accident. Yeah, auxiliary converter is also purpose to operate other things. And conventional converters. So conventional converters, in that case, you can see we have a battery, and that is battery DC link will be there, and this simple 3 lamp converter. So yes, in that time, yeah, the motor is AC motor basically. That's why this conventional system we can use. So it's stored energy having the battery, okay, and that battery again convert in the DC. Provide battery will provide the DC and it will convert to the AC as per your requirement. So simply cooperate or switching these 6 switches, okay, as per your requirement to control the speed of the motor. And yes, this motor generator will convert to generate a power and feed back to the motor. So this is the system of this system is called a power converter basically. But that is not automatically done. That is not automatically done. It is required a pulse. And how can generate that pulse? How can generate that pulse? Yes, that is done by the algorithm. Algorithm is nothing but a logic circuit of the this system. So yes, suppose if you and which semester is it? Basics. Okay, fine. So in this system, suppose if you are 120 mode operation you are doing, or simple 180-degree mode operation you are doing. So that is simply give the constant speed. And if you are wearing the pulse, means all 6 pulse, if you are wearing as per your requirement, the speed will be valid. Okay, and yes, when this motor work as a generator, so in that time we are not providing the pulse. You can see these diode anti-parallel diodes are there. These diodes are work as a rectifier. So rectifier, in that case, that AC power will feed back to the battery. So that is the conventional system. Okay. Now this conventional system which is having a low voltage energy system. Yes, here the previous one was high voltage energy system, and yes, here that is a low voltage energy source if it is there. So here we can use the DC to DC converter, and it is called yes, this is the low voltage energy source, and yes, this is the DC to DC converter, and yes, in that case we generate a high voltage or step of this DC voltage by this DC-DC converter, and yes, maintain to constant and not maintain to constant variable voltage we are getting, and that variable voltage again we are having in the input side of this motor generator side, and that is converted to the AC. Okay, and same phenomena will be done. Only in that case, this DC-DC converter work as a bypass motor. Okay. And yes, suppose if you have multiple inputs, in that case, we can use this separate DC-DC converter to connect this separate DC link. Okay. So again, we can say that if you have a single battery, so you can use the previous one. If you have a multiple battery, so you can use this system to get a variable speed of this motor. And yes, that is very important thing when using this converter. Converter is I'm not saying to simply to control the switches. This theoretical is very simple to provide the pulse and generator to get a variable speed, but it is not as simple. Okay, because for single switch, for controlling a single switch will require a multiple system. Like first, for switching of one, I'm taking a single switch. Okay, suppose this is the switch. I'm taking a single switch and this is IGBT suppose. Okay, integrated bipolar transistor we are using. So suppose this is a system, that is a AC supply is there, and if you want to take a variable DC, so and this is a load, suppose this is simple load. What will happen? What will happen when you provide a supply? There is no operation, or we can say and negative voltage will be there. Okay, but when you provide a gate pulse, your operation will be happen. Okay, so how can we done? So I am taking a simple experiment by the. This is a AC voltage because I am using a AC supply here, or better we can use the DC. Better, no issue. Suppose we have a AC supply, or that is the example of battery, so we'll take a AC. Suppose this is the circuit, and we have a supply, that is a DC supply, VPN. So how can get in variable DC across the load? So simply as a theoretical, when you provide the pulse, and pulse means it is a simple pulse. As per your requirement, you can vary the bandwidth or duty cycle of this pulse and get a variable voltage. So suppose this is our pulse, 50% on and 50% off. Same, this is T on time and that is a T off time. Okay, and that is total turn on time. Okay, so you know, in this time, this switch is on. So we are getting an output on this time only. And when switch is off, your voltage will be not there. Getting my point? So what will happen? What will happen? How much voltage we are getting? Suppose the magnitude input voltage is at 10 volt. I am taking as example actually. So suppose that input voltage is at 10 volt and 50% on and 50% off. What will happen? The average voltage is what? That is a 5 volt, because that is a turn on time is 50% turn on time. That magnitude was 10 volts only, and remaining 50% that voltage is 0. So when you average, so that how much voltage will be? Okay, that is a 5 volts. So the average voltage will be 5. So you can see by varying the duty cycle, when you vary the duty cycle, we can get a variable voltage, isn't it? So that is the feature with this IGBT. Okay, for variation of the DC voltage, there is no possibility by connecting the resistance. यदि आप DC voltage को vary करना चाहते हो, how can you vary the DC voltage? कैसे vary करते हो? Any provision is there? Network पर रहे होंगे third sem. How can you get the variable voltage? Okay, so there is no provision without connection of the resistance. When you connect the resistance, a drop will be there and voltage will be there. Simply that is a voltage divider circuit you can use for the reducing the voltage. So there is no direct provision. Okay, but AC voltage we have a transformer. Variac is there, an auto transformer. So by variation of varying the knob, we can get a variable voltage. But in the DC, there is no direct provision. Okay, so in that case, the easy thing, and yes, one more thing, यहाँ पे जो losses है that is very negligible. Okay, so जब losses कम होंगे तो definitely the efficiency will be more. But as a theoretical, that is very simple. Theoretically, it is very simple. The thing is that how can generate this pulse? That is important. And yes, that pulse will as per your requirement. Getting my point? As per our requirement. कहाँ हो रही है requirement आपकी? Suppose same circuit I am using here DC motor. Suppose this is the DC motor. Just I am taking example actually. ये जो DC motor है, that is the armature A AA. We are taking AA. Okay, and we want to vary the speed. Okay, so suppose if you want a fixed speed, so you can maintain a 50% duty cycle and get a speed. Suppose at a 10 volt, speed is 100 RPM. So at a 5 voltage that will be reduced just half, isn't it? तो speed जो हो जाएगी वो half हो जाएगी. But you have not option to vary the speed. So उसके लिए हमें क्या करना पड़ेगा? To vary the turn on turn off time. Getting my point? कैसे वेरी करोगे? Like this, है ना? Turn on time कम कर दिया, turn off time ज़्यादा कर दिया. तो जब आपका turn on time कम होगा तो definitely the magnitude of the DC voltage will be less, है ना? Near to the zero. जैसा आप करोगे on time जितना कम रखोगे voltage उतना कम होगा, on time जितना बढ़ाओगे उसका voltage उतना ज़्यादा होगा, isn't it? तो इस logic को develop करने के लिए क्या करना पड़ेगा? Suppose थ्रोटल इज देयर, आप लोग ने टू व्हीलर यूज किया होगा या फिर जो इलेक्ट्रिफाइड व्हीकल यूज किया होगा उसमें क्या होता है? थ्रोटल होता है. थ्रोटल क्या करता है? दैट विल बी वेरी द स्पीड वेरी नहीं करता है. एक्चुअली दैट ऑपरेशन इज टू वेरी द स्पीड, बट दैट विल बी वेरी द
motion,
नो, दैट इज वेरी द
impulse.
pulse width. Actually that is very the pulse width. Getting my point? So that is not done by the directly, and yes, that is also not done by the manually. Manually कहाँ पे करते हो आप? Speed वैल्यू कहीं करते हो आप? क्या? Speed कहीं वेरी करते हो आप? Physically अभी यहाँ पे कहीं है ऐसा जहाँ पे आपको स्पीड वेरी करने की जरूरत पड़ती है? हाँ? Fan है ना? So fan also having a regulator.
Yes, sir.
And regulator भी अलग-अलग टाइप के होते हैं. 5 स्पीड्स के होते हैं और इनफाइनाइट स्पीड के होते हैं, जिसको बोलते हैं स्मूथ कंट्रोल. सो स्मूथ कंट्रोल क्या होता है? देयर ट्रांजिस्टर इज देयर. ओके, एक्चुअली दैट रेगुलेटर इज अ डायर कंट्रोल ट्राय. दैट इज द बेस्ट एग्जांपल ऑफ कन्वर्टर. दैट इज द बेस्ट एग्जांपल ऑफ कन्वर्टर, बेसिक कन्वर्टर. सिंपली यू कैन वेरी द pulse and get a variable voltage. So that will be done by the manually. We are changing the knob by manually, isn't it? So manually change करोगे तो definitely that will be vary the firing angle, and firing angle will change, then voltage also change. But that is done in transistor, and that is a AC. That is controlling AC voltage. That is also called a AC chopper. वो AC chopper है, isn't it? So that is, the point is that we can generate this pulse as per your requirement. Our requirement कहाँ से पता चलेगी? How can find that requirement? Without feedback we cannot find it. So suppose जो throttle operated two wheeler है electric vehicle, उसमें आपका feedback क्या है? How much feedback we are using? अच्छा, आईसी इंजन बेस्ड आप टू व्हीलर चलाते हो, कौन-कौन से फीडबैक्स लेते हो?
Speed. देखते हैं क्या है?
आई.
Yes, sir.
Yes. और definitely feedback is I. And we are controlling, and brain is your converter.
Decide करता है.
Decide करेगा. And this is also a DC converter.
Yes, sir.
To give the command to the particular
Hands
and foot, है ना, जो भी आपको ब्रेक लगाना है. So feedback ऐसा आई ने आपको बताया, then उसके बाद कि कोई ऑब्जेक्ट आए तो give the brake, provide the brake.
Yes, sir.
So this thing. So here electric vehicle में of course that primary vision is there. Vision के according we can apply the brake, or we can remove the foot from the accelerator.
Yes, sir.
Isn't it? तो उसमें जब एक्सेलेरेटर से हटाया तो सप्लाई से आपने डिस्कनेक्ट कर दिया, वी आर प्रोवाइडिंग द मैनुअल ब्रेकिंग एंड रीजनरेटिव ब्रेकिंग एज वेल. ओके, तो वो जो फीडबैक है दैट इज व्हाट. हां, यस, वन मोर थिंग. अब आपको क्या करना है? रोड खाली है, यू आर प्रेसिंग द एक्सेलेरेटर. आप क्या कर रहे हैं? थ्रोटल को आपने बढ़ाया. तो आपने क्या किया? एक्सेलेरेटर बढ़ाया किसमें? आईसी इंजन में तो आपने एक्सेलेरेटर, बट इन इलेक्ट्रिक व्हीकल वी आर वेयरिंग द pulse. So that is the basic example for single switch operation we are listening. तो अब ये क्या होगा कि when you provide the variable pulse, so again this is not a simple कि आपने बता दिया तो वो हो जाएगा. No, there is a algorithm, there is a logic, है ना, कि when you are providing the accelerator, you are required to vary the width of the on time pulse. Getting my point? So same thing will be happen in this here, and yes, that will be done in the digital control, isn't it? अब digital controller क्या है? What is the digital control? Yes, whatever logic you have written, logic it means, suppose आप किसी प्लेस पे जाना चाहते हो एंड टू पीपल आर देयर, वो दोनों एक ही प्लेस पे जाना चाहते हैं एंड वी आर गिविंग द सेपरेट टास्क टू गो ऑन द पर्टिकुलर प्लेस, सो दैट बोथ द पीपल आर थिंकिंग डिफरेंट वे कि मुझे यहाँ से जाना है, यहाँ से जाना है, यहाँ से जाना है, यहाँ से जाना है, ये लेना है, ये करना है, ये करना है, काइंड ऑफ, ठीक है। दूसरा अपने अकॉर्डिंग करेगा, सो देयर इज अ मल्टीपल वे, सो अकॉर्डिंग टू दैट पीपल लॉजिक दे हैव डेवलप्ड द प्रोग्राम, है ना, वो प्रोग्राम अपने अकॉर्डिंग या लॉजिक अपने अकॉर्डिंग या वे अपने अकॉर्डिंग डेवलप करेगा, उस वे को आप अप्लाई करो, दैट इज द थिंग। सो सेम थिंग वी कैन राइट इन द प्रोग्राम, वी कैन राइट दैट प्रोग्राम एंड स्टोर इन द डिजिटल कंट्रोलर। अब डिजिटल कंट्रोलर में क्या है, वो लॉजिक है कि जब कोई एक्सीलरेटर जब मैं दूंगा तो मुझे क्या करना है, विड्थ को इंक्रीज करना है, सो डेफिनेटली अकॉर्डिंग टू दैट लॉजिक द पल्स विल बी अप्लाई अक्रॉस द switches, all electronic switches, so they accordingly that will be valid, that is the point. Okay, now so many things are there, we are not including, actually the laptop also not having this thing, laptop connected, otherwise I will show the controller. The point is that all the things related to the power electronics, what will happen when these systems are connected with the grid, what will happen? As per our requirement, we have connected the converters across the grid to take up power or feed up power, है ना, यही कर रहे हैं ना। यदि फास्ट चार्जर आपने यूज किया है तो चार्जिंग द इलेक्ट्रिक व्हीकल, तो क्या किया था आपने, बैटरी थी आपने, राइट, एसी आपका सोर्स था, ग्रिड में एसी सप्लाई है जनरली, हियर इन एमपी देयर इज नो डीसी ग्रिड, AC grid is there, AC से आपने इसको DC में बनाया by using the converter and feeding to the battery, isn't it? So when you connect this type of converter, and yes, if you are feeding to the grid, again the bidirectional converter will work, DC से AC में होगा, AC से फिर grid में चला जाएगा. So this bidirectional power conversion, what we are considering, converter is there, and converter is a major source of harmonics. It is a major source of harmonics. Nowadays we are using a semiconductor based device, all the devices or appliances are based on the semiconductor. Getting my point? Semiconductor means I am talking about the power electronics. कैसे, कोई appliance बताओ जिसको आपने यूज किया जिसमें power electronics बता सकते हो? Yes, all the appliances nowadays, all the appliances we are using a power electronic devices or switches like induction, fridge, AC, जितने भी आप appliances बताएंगे, I think all appliances having a power electronics, and power electronics device is a major source of harmonics that will be generate a harmony. When and what problem will create a harmony? That will be deteriorate the quality of the power. That will be deteriorate the quality of power. And if you are deteriorate the quality of power, what will happen? That will also deteriorate the efficiency of the appliances. अभी क्या है, आप जो यूज करते हो, पहले क्या यूज करते थे, बल्ब यूज करते थे, बल्ब इज डिजाइन हुआ, डेवलप्ड बाय टंगस्टन वायर, simply, and that load is a resistive load. That is a load is a resistive. Nowadays, for lighting, we are using a LED light. LED is again a semiconductor device, and that will be create a spike through the supply, and that will be deteriorate the supply. So again, to require to filter out these harmonies from the source. Getting my point? आप उसी से पावर ले रहे हैं और उसी को डिटोरिएट कर रहे हैं, ठीक है। अच्छा, फायदा क्या हुआ हमें इससे? When जब हम टंगस्टन बेस्ड बल्ब यूज करते थे, what is the benefit that there is no power factor loss. पावर फैक्टर आपका, there is no harmonics, ठीक है, पावर फैक्टर यूनिटी हुआ करता था, ठीक है, हार्मोनिक्स नहीं होता, जब हार्मोनिक्स नहीं होते थे तो आपको उसके लिए फिल्टर की रिक्वायरमेंट है ना। अब क्या कर रहे हो आप अपने एंड पे इलेक्ट्रॉनिक डिवाइस यूज कर रहे हो एंड वी आर डिटोरिएट द सप्लाई। अब सप्लाई जब डिटोरिएट हो रही है तो आपके जो अप्लायंसेस है दैट विल बी डैमेज इन वेरी शॉर्ट ड्यूरेशन। जैसे फैन हुआ, पहले जो फैन होते थे वो फैन जो होते थे वो रेजिस्टेंस कंट्रोल होते थे and now we are using a direct control trial, then light will be deteriorated. ठीक है, so many things are there. So to maintain, to remove that harmonics will require a filter. Either we can use the conventional filter or active filter. So active filter में series active filter is there and shunt active filter is there. For the shunt active filter for current harmonics we can remove. So we'll discuss some things. So that we already discussed and that harmonics will deteriorate the power quality, voltage frequency, waveform, and that will create a over voltage, under voltage, sexual, okay, sexual, and that will be deteriorate the waveform, okay, and it is create a harmonics distortion. So these both distortion, harmonic distortion are there. Voltage distortion and current distortion. Okay, so voltage distortion we can done by series compensator and current harmonics done by the shunt compensator. So yes, source of harmonics that is rectifier inverter. Yes, rectifier inverter it means again we are talking about the converter which is already using in the electric vehicle. Okay, and static watt generator is there. Switching power supplies are, as you know, अभी मैंने थोड़ी देर पहले बताया था कि हम लोग क्या क्या यूज कर सकते हैं, क्या क्या सिस्टम जो हार्मोनिक्स क्रिएट करते हैं. तो that is a switch power supply. That is SMPS. That will create a harmonics. DC motor drives. Adjustable DC motor drive means washing machine. Okay, and fridge also. So that is DC motor drive. And adjustable frequency AC motor drive. AC motor drive means again that is a regulator. Uninterrupted power supply UPS. Arc furnace that is in industry they are using this arc furnace that is a source of the harmonics. Static motor starter. Static motor starter is nothing but a electronics based circuitry. Okay, so that is a static motor starter. And electronic lighting glass. These are and etc. So these are the sources of harmonics and effects of harmonics. What will happen when harmonic will be happen or come in the system? Okay, so added efficiency losses to system composed by electrical installation and equipment. And unexpected resonance will be there. It means malfunctioning will be there. Suppose if your power quality is not good and you are using a system which is required a pure sinusoidal supply. So what will happen? That malfunctioning will be there. Okay, आप इसको ऐसे नोटिस कर सकते हो जब यदि वोल्टेज फ्लक्चुएट होता है तो समटाइम जब आप वॉशिंग मशीन या फैन यूज कर रहे हो तो कभी उसकी स्पीड ज्यादा होती है कभी उसकी स्पीड कम होती है. So this type of function will be there. Okay, when we introduce the harmonics in the system, insulation failure will be there if harmonics come in the picture or in the supply or it is deteriorate the power quality. Overloading, overheating will be there, and disturbance in electronic equipment causing a logical fault in digital circuitry, especially in relay circuitry. That will be create a problem when harmonics power quality issue will be there. Okay, and unwanted overload condition will be there. Malfunction of motor and generator. Yes, malfunctioning means as per your requirement that will be not function. कभी ज़्यादा हो जाएगी स्पीड, कभी कम हो जाएगी स्पीड. यदि जनरेटर की स्पीड कम ज़्यादा होगी तो what will happen? जनरेटर की स्पीड, कोई जनरेटिंग प्लांट है and we are in that place we are using a synchronous generator. What will happen? Frequency will be change. जब frequency change होगी तो all system will be create a problem. So that is the thing. And yes, unwanted circuit breaker tripping and fuse blower. यदि इस टाइप का यदि पावर क्वालिटी में प्रॉब्लम होगी तो डेफिनेटली सर्किट ब्रेकर जो जिस टाइम को इसको ऑपरेट होना चाहिए वो कभी भी ऑपरेट हो जाएगा, ठीक है। एंड सिमिलरली विद द फ्लूइड फ्यूल विथ या relay will be not work properly. Interference with the communication network, yes. When introduce the harmonics in the power quality, power, what will happen? The distortion will be there, so the frequency will be varied. Okay, so frequency will be varied means that will create a problem or interference in the communication system. Okay, when it is near to the power lines. So these are the some harmonics present in distribution system. You can see that is minimum and maximum value of the current TSD in percentage. You can see without UPS, light, fan. So these are the TSD in percentage. You can see that is near about 160%. And when using a filter, or we can say without with filter, we can say if you are using a filter, the TSD will be less than 6%. Okay, so filter requirement will be more. If you are not using a filter, that deterioration will be there and so many problems will be happen in the power system. Okay, so that is the importance of the filter. So yes, for that problem we can sort out. Yes, this is the graph actually. You can see 160%, more than 160% TSD will be there when filter was not there. And when using a filter, so you can see that 6% TSD will be there. Okay, minimum and maximum, that is the TSD. So if you are not using a filter, this 160% TSD will be happen. So how can we sort out? So we'll require a filter. So you can see by graph you can easily see when you're using a filter, so TSD will be less than 6%. And yes, IEEE standard that required to maintain within 5%. Okay, so we'll require a filter. So we have option. So that is a solution. That is a classical solution is passive filter. Passive filter is nothing but a simple combination of RLC circuit. Okay, and this thyristor switch capacitor. Thyristor switch capacitor is nothing but a combination of semiconductor switch and capacitor. And yes, thyristor control reactor, that is also a electronics based converter. Active solution, it is also having a electronics switches which is control the harmonics. हार्मोनिक्स को कम करने के लिए आगे जो किससे जनरेट हुई थी, तो इलेक्ट्रॉनिक डिवाइस के कनेक्ट होने से जनरेट हुई थी, उसको हम वापस इलेक्ट्रॉनिक डिवाइस के यूज से रिमूव कर सकते हैं. So that is the benefit with the electronic devices. Okay, so yes, we have option active filter, that is series active filter and shunt active filter, and hybrid power filter is also there. Hybrid power filter means both type of filtration is required, like voltage harmonics or current harmonics. In that case, we use the hybrid active filters. Okay, and active harmonics filter means why it is called active harmonics? Passive, it means will give the fixed value of inductor and capacitor. Getting my point? अच्छा, एक और अच्छी चीज मेरे दिमाग में, how can we vary the inductance? अब मैंने जैसे बोला कि हार्मोनिक्स को रिड्यूस करने के लिए we can use the inductor and capacitor. So for the variation of the inductor, we can do that. कर सकते हैं inductance को vary. How can vary the inductance? आप लोगों ने एक्सपेरिमेंट भी किया होगा, चोक कॉइल वाला एक एक्सपेरिमेंट किया होगा.
Number of turns को
Yeah, that is possible. That is done by the auto transformer. एक और किया होगा, कोर के ईयर गैप को कम करके किया था, RL को right? So we can change the air gap, so we can vary the inductance, isn't it? And how can vary the capacitance? Capacitance को कैसे vary करें?
Let's get distance come. So let's get distance come.
So again to change the design,
Yes, sir.
है ना? Capacitance को यदि vary करना है तो to change the distance of the plate. So definitely to require change the design, है ना? So to vary this capacitance, we have option to done by polyphonic device. वहाँ पे फिर हमारे पास polyphonic option. And why we are using a polyphonic? Because that is a efficiency is high, losses will be less. Okay, so we have option to filter out the harmonics. Yeah, classification of preferential current estimation algorithm. These are the different algorithms to generate a pulse. Okay, to control the switches. Okay, now these are the topologies of active filter. That is, this is the shunt active filter, and this is the series active filter. So series shunt active filter is directly connected with this line. This is a line diagram, and this is connected by the transformer. Okay, so that is a series filter. Okay, and this filter is nothing but a yeah, these are the some hybrid filter. You can see it is also having a shunt and shunt passive. This is a shunt, and we also connected one inductance, fixed value of inductance with this line. So that is a hybrid system. And here you can see this is a series filter, but additionally we have connected one shunt passive filter. That is a fixed value. Here we are changing the capacitance by varying the pulse of this semiconductor switch. Here we are varying the voltage or the value of the capacitance by varying the pulse of this semiconductor switches. And here that is the series active filter. And yes, you can see it is a shunt, and here that is connected as a series. Okay, so that is also a hybrid system. So these are the comparison to hybrid active filter and how active filter. And yes, I am taking the example of the shunt active filter. So in the shunt active filter is what is the important thing with that? How can it will work? You can see this is the sinusoidal waveform. Okay, and this is a load. Load is non-linear load. Non-linear load means it is mandatory to having a having a polyphonic switches. So semiconductors, when you using a semiconductor switches or converter, that will be deteriorate the supply. You can see this is a supply. When you connect the load, so the voltage will be, current will be changed. You can see the shape of the current. This is not actually sinusoidal. It is similar like amp shape. Okay, so when it is having a harmonics, when it is having the shape of the waveform will be changed. As I discussed previously, what will happen? What will happen? That when you increase the when you introduce the harmonics, that waveform will be deteriorate of the current waveform. That will be affect to the source as well. Suppose यहाँ पे और कोई दूसरा source connect है, isn't it? Suppose आप अपने घर में बहुत नॉन-लीनियर लोड यूज कर रहे हो and बगल वाले घर में आप जिस पॉइंट से आपका कनेक्शन आया, जिस ट्रांसफार्मर से, बगल वाले के घर में भी उसी ट्रांसफार्मर से कनेक्शन आया. What will happen? That harmonic will affect to the other home as well. है ना? क्योंकि you are a introducer of the harmonics, isn't it? तो यहाँ पे यदि कोई और दूसरा लोड कनेक्टेड है, मतलब दूसरा और लोड कनेक्टेड है, that will be also affect to the load. हम दूसरे घर का एग्जांपल लेते हैं. दूसरे जैसे एक रूम में नॉन लीनियर लोड है और एक रूम आपका नॉर्मल है. So that affect to the other room as well. है ना? अदर रूम के जो अप्लायंसेस हैं उसको अफेक्ट करेगा. जनरली टीवी क्यों डैमेज होती है? जो digital damage. That is the purpose. That is the reason. Okay. So how can we remove that? So suppose this is the shape of a deteriorate waveform. In just opposite current it when lambda, and add on this waveform. So what will happen? That will be not effect to the source. यदि इसमें कोई demand आ रही है, suppose it is demanding a current, so that current will provide by this filter. So that will not affect to the source. So we can install this filter either in the load end or source end. Suppose generally in the load end we are not installing, only industry are installing. हम हमारे लिए कहाँ होता है, सब स्टेशन पे होता है. Electricity board are not charging this time to deteriorate the power, isn't it? They are charged by industry only because they are producer of harmonics, higher producer of harmonics. So according to the power factor or the reactive power, that will be charged. Okay, so simple. The function is what of the subtractive filter? Whatever current is required, just opposite phase will provide the current. So these two current will add on and find this sinusoidal. So whatever current is required, that will be generated by this subtractive filter. Getting my point? And how decide to develop this current? By taking a feedback. Which feedback? This load current. So I am taking a load current feedback according to will regulate this capacitance value and generate a capacitive current. And that capacitive current add on in this load current and it will make a sinusoidal on the supply. It means that will be not affected to the source side. It is automatically maintained by this end of the load. Is it clear? So that is the function of subtractive filter. Yes. How can we design? Simple. This is a three-phase system. Okay, three-bus system. And yes, three-line system actually. And yes, this is the converter as well. अभी यहाँ पे क्या लगा है? Capacitor लगा है. You know, this is the DC link. Is it clear? So whatever DC voltage or DC current is required, that capacitance will vary and generate a capacitive current and feeding to the load. So this type of function will done in the three phases. Getting my point? And yes, you can see I have taken the around 1000 voltage as a primary voltage. So dV by dt stress across the switches you can see. This is the dV by dt stress across the switch. So I am taking these two switches. Okay. So these switches, you can see the voltage stress across individual switches around 1000. I am applying the voltage around 1000 volt. So voltage stress around 1000 volt each switches. And according to the current, you can see that is the pattern. Okay, you can see this is the pattern of the current. This is sinusoidal. No. This is sinusoidal, but exactly not sinusoidal. It will spikes are there. Spikes are there. You can see like this. This is purple one, and they're just opposite blue one. So this is looking a sinusoidal like this, but this is not actually sinusoidal. The pulse will be there. Okay. So this type of pulse will create in the supply, isn't it? Just because of having a harmonics. So this is the algorithm. How can we generate a pulse? You can see we have taken example as source voltage, feedback as a source voltage, there is a source current, and we also taken a feedback as a voltage as well. Okay, we have taken a feedback as a DC voltage. Okay, which DC voltage? This DC voltage. We have taken as a feedback. Okay, so source voltage, source current, and this DC link voltage we have taken as a feedback to generate a compensating current. So you can see we have taken this DC, actual DC voltage, and reference DC voltage. Suppose if you want to maintain a particular value of the DC voltage. So we can set here, and actual voltage and actual current we have taken from the source. And yes, according to we have convert this ABCD to alpha beta, okay, and we find the power, and according to that power we have developed this I alpha and I beta current, and this again I beta I alpha I beta current with ABC, because we require three compensating current, and that compensating current again we compare with the source current and generate a gating pulse. So this is the logic to generate a. Here we are using a hysteresis control. So hysteresis control, this is nothing but a band actually. We'll pass these two waveform, and that will be create a error, and that error will consider as a pulse. Okay. So these pulse to operate these switches. Okay. 6 pulse will generate, and these pulse will operate to generate a compensating current, isn't it? So मैंने थोड़ी देर पहले बोला था कि in study that is very simple. In study it is very simple to talk to give a pulse, but this is not actually. That is the logic to generate a pulse. Okay, so different converter as per the requirement will develop the algorithm. This is nothing but an algorithm to generate a compensating current. So different way to generate, and engineers are developed or researchers are developed to generate this compensating current. Okay. So now to design of DC voltage and DC capacitor and filter inductor, these are the formula to design a filter current, and some basic parameter which is using in simulation. And yes, you can see, you can easily observe this is a supply. This is a sinusoidal three-phase supply, isn't it? And this is the okay. And yes, this is the filter current actually. So filter current, filter voltage. In this time, the filter voltage will be at this point, 0.01. Filter voltage will be sinusoidal. After that, because the filtration is required filter current will be done. So you can see this is a source current. Forget about this. First, this is a source voltage. This is a source current, and this is the load current. So you can see load current always in shape of amp. You can see as I told, because it is having a harmonics. So load current हमेशा आपका ऐसा रहेगा, isn't it? And this current is a compensating current, which is generated by the filter. Okay, ये current और इस current के साथ add होगा, तो finally you can see your source current will be sinusoidal. So when you adding means just opposite base current we have developed as a compensating current, and adding with the load current, so it will be make a sinusoidal current. Okay, so that is the function of the filter. So you can see when filter will activate a 0.1, you can see your source current will be sinusoidal, and your load current as usual. Okay, so when you install the filter or when you active the filter, your source current goes to sinusoidal. Okay, and yes, one more important thing is the active filter as per your requirement. ये तो होगा नहीं कि मैं इंडक्शन यूज कर रहा हूँ तो फ्रीज यूज नहीं करूंगा, है ना, या दोनों को यूज करूंगा, या किसी रूम में एक्टिव कराऊंगा किसी रूम में नहीं. तो दैट इज द वेरिएबल source of the harmonics. Okay, so as per your requirement, that will be generate a compensating current. And when you use the conventional filter or passive, that is providing a fixed value of the current, that will give the fixed value of the current. वो variable नहीं होगा. Getting my point? क्योंकि वो आपने fixed value कर रहा है. But in the active filter, as per your requirement, you can develop this filter current, isn't it? Because we are using a feedback system. Okay, we are taking a feedback. So as per your requirement, active filter will be operated. Okay, so that is the advantage of the active filter. these are the simulation result. As you know, this is the load current and source current actually. After before filtering, you can see that TSD is 24.47%, isn't it? After filter, you can see that current will be TSD will be 1.88%, means less than 5%. Okay, so it is mandatory to install a filter either in the load end or source end. Okay, we can install filter both the place. So these are the actually experimental. We have done same thing. Some parameters which is using to develop a hardware prototype. Yes, these are the hardware result actually. Again, that is a voltage, that is a current, source current, that is a filter current. Sorry, load current, and this is the filter current, and finally this is the DC. DC means what? Across the converter. So that voltage, DC voltage will be constant. You can see when you active the filter at this point, this filter current will be developed, both are added, and your source current will be sinusoidal, and your voltage is already sinusoidal. Getting my point? So similarly for the ADS, the filter current on more, means filter active, so this current will be developed, and yes, in this place, these are the nothing at this end as well. Okay, before the active the filter, your source current will be non-sinusoidal, and after active this filter, this source current will be sinusoidal. Okay, and yes, these are the TSD of the three-phase current. Okay, so before the filtering, the TSD was around 24.7, means this is maximum 24.7. Okay, and you can see usually you can see here major responsible of third harmonics, fifth harmonics, and 11th and 13th and 17th also. So these third harmonics, fifth harmonics, 11th, 13th, these are the responsible to deteriorate the waveform. Okay, and you can see after filtration, now your waveform is similar to sinusoidal. You can see that TSD is 1.4%. Sorry, that is a 4.4%, not a 1.4%. That is a 4.4%, and you can see the magnitude of the third harmonic will be reduced. You can see here, and fifth also, and 11th is neglected, and 13th totally negligible. 17th is totally negligible, isn't it? So that is the benefit with the filter. So yes.
Likewise, sir.
Yes, no. So thank you so much. If you have any doubt, query, so you can ask me. Welcome to ask. So shall I continue? I have also.
सर वैसे एक मुझे बारह से एक थोड़ा सा सिर्फ आर्टिकल डिस्कशन के लिए पेपर आप
हाँ, sure, I will read this. Okay, fine. Yes, whatever I have presented, if you have any doubt, queries, so you can really to ask. Okay, any kind of, maybe your question technical or not technical. So that is all question are guys, especially students. Yes.
Without it, किसी को any questions पूछ लो.
सर एक्चुअली एक क्वेश्चन सर, आप जब बता रहे थे कि वो जो चार्जर है एक्चुअली क्या है, जैसे एक बार आपने गाड़ी चार्ज करने के बाद लगातार यूज करते जा रहे हैं, लाइक 1-1.5 साल तक जब यूज कर रहे हैं, तो वो पता नहीं रिपेयरिंग क्यों मांगता है, मतलब या तो वो चार्ज स्लो करता है या फिर वो होना चाहिए जो 1-1.5 घंटे में हो रहा था वो उसका इंक्रीज टाइम भी बढ़ जाता है फिर.
Okay, yes, thank you. There is a two reason and in your question having a two question. Okay, one is why it is taking a more time and why it is deteriorating. Actually, the power electronics devices having a life of in hours. इसमें होती है hours में करना. Okay, so that is the first reason. Okay, so according to the life that will be over. Secondly, how it will be take a time to charge because that is depends on the battery which is you are using. Okay, so the cycle will be deteriorating. Charging and discharging cycle will be deteriorating. So that's why it will take a more time or maybe it will be take a short time to charge. Okay, but the backup will be less. Okay, so that is the reason behind. Yes. Anything else?
तो आप लोगों को लैब 7 में जाना है अभी निकल जाओ. मैंने लिखा है मैसेज. तो थर्ड सन में only EX students. Please proceed to 11/7 for virtual lab session. तुम रुक जाओ. तुम वहाँ चले जाओ आगे.
संजन